Good morning, ladies and gentlemen. Welcome to Good Burger, home of the Good Burger. May I take your order? Continuing topic 3, we're going to be evaluating algebraic expressions. And so in the first half of the topic, we were reviewing order of operations. We were taking situations with words and making expressions. And now we're going to take expressions that are already given, and we're going to see how much they're worth. We're going to evaluate them. And they might include whole numbers, decimals, or fractions. So we're actually going to start at the bottom, and we're going to evaluate this expression 50 minus t when t equals different values. And so the idea here is, right, if you have an expression and they tell you to check the value with different values, or check the value of the expression with different values for the variables. Essentially what they're asking you to do is take this variable and then plug in each value. So the first one would look like that. And then you would have one that looked like that. And then you would have one that looked like that. And so we know that variables represent quantities that change. So let's say that it's t represents tater tots. And I've started with 50 tater tots on my plate. And I want to know how many tater tots I'll have left if I take some away. And in the first situation, I take away 10 tater tots. So how many would I have left? Right, that'd be 40. In the second situation, I've eaten 20 of my tater tots. I've taken 20 away. So I would have 30 left. And then finally, in the last situation, I took 25 away. So I would have 25 left. The whole idea here is that you are trying to figure out what this expression is worth for possible values. Right? It works the same with decimals and fractions. Right? So if you want to pause the screen right now and kind of try out what these are saying and then check your work, that's totally okay. If you want to keep going and work through them with me, that's also okay. Right? But the idea here is that I have this expression, and I want to know what's going to happen if a happened to equal 10. So what I'm going to do here is I'm just going to rewrite this. So I'm actually going to erase what I have. Right? Maybe. It's going to do the thing again, isn't it? Nope. There we go. All right. So I had 12, and now where I had a, I have 10. Order of operations tells me that I need to multiply before I divide as I move left to right. So I'm going to satisfy 12 times 10, and that's 120 first. And then I'm going to divide. And if you'll recall, you can always do the numbers that don't end in 0 first. 12 divided by 4 is 3. And then plug your 0 back on. And then finally, that is my answer. So again, all you're doing is taking the variable out and plugging in the value that they give you, and then making sure to solve all the operations. The key to this one was making sure you recognize that this and this are multiplication. Why don't you pause the screen and try the next one? You'll notice here when I wrote it for the s, I just replaced it with 1/3. You don't necessarily need the parentheses. You could have just written it like that, and that would be okay too, as long as you are aware that the squared is not just for the 1, it's for the whole fraction. You'll notice too I did some margin math here, 1/3 times 1/3, and then also over here when I had to solve my division of fractions, so my multiplication expression as well. And I got 243. Notice that none of the computation is new. Order of operations, review. Multiplying fractions, dividing fractions, review. Multiplying whole numbers, adding decimals, review. What's new here is that we are starting with a variable, and then we are substituting in a value. Okay. So Eric collects miniature cars. He has one large case that has 20 cars. He also has 3 same size smaller cases filled with cars. Let n equal the number of cars in each smaller case. How many miniature cars does Eric have if each smaller case holds 10 cars, 12 cars, or 14 cars? So we're really solving three different problems here. One if n equals 10, one if n equals 12, and one if n equals 14. But before I can solve any of that, I have to write an expression. So, what's important here? Well, I notice that he has one large case that has 20 cars. So I know I have at least 20 cars. And then I'm going to add to that, let's see here, I have 3 smaller cases filled with cars. And they're all the same size, but I don't know how many are in each case. So that means that I have 3 smaller cases with some amount of cars inside each one. Right now, if you don't understand the expression I wrote, I want you to pause and come and get me. If you do understand where the expression came from, I want you to pause and see if you can evaluate it for each different value. There are the values for each given variable. I am okay with this amount of work. I'm okay with you doing this multiplication in your head. I would, however, want to see how you plugged the variable in like that. Again, see me if you have questions. Otherwise, you can log on to the online textbook and complete the independent practice for 3.5. Have a great day.